So next example is find the convolution sum of x of n, which is alpha to the power n u of n, and h of n is equal to u of n. The examples now you can observe that all are infinite values u of n. Okay, sometimes you might get x of n and h of n are finite. Okay, so that is another set of example which we will consider later. Okay, so now your first thing what you have to do is y of n equal to write the equation summation k equal to minus infinity to plus infinity x of k h of n minus k. This is convolution sum derivation which you have got. Now summation k equal to minus infinity to plus infinity. What is x of k? Replace n by k. So alpha to the power k u of k, right? And h of n minus k. Replace n by n minus k. So it is u of n minus k. So you know that u of k samples are 1, u of n minus k samples are 1. Just you need to get where the values exist and where the values do not exist for y of n. Keep alpha to the power k as it is. Okay, so now again I will try to draw u of k. Zero, 1, 2, 3, 4 and so on towards infinity, plus infinity, amplitude 1, right? Next you have u of n minus k. Again u of minus k shifted by n. So u of minus k starts at 0. At 0. U of minus k, reflected version of u of k. Towards minus infinity, right? Amplitude 1. I have simply written u of minus k. Now plus n. Plus n, as I told, n can be less than 0 or n can be greater than 0. So I will try to write it as somewhere here n value which is greater than or equal to greater than 0, right? Now this is your u of minus k shifted by n. Now you have to again find what is y of n for n. Earlier it was u of minus k plus n minus 3. Now it is n greater than 0, greater than or equal to 0. What is y of n when n is less than 0? N means y of n when it is overlapping. Okay, we are trying to check when n is less than 0. Shift towards left completely. N less than 0. All the samples should be all the samples of this should be towards left side, so that I have the n value less than 0. Something like minus 1, minus 2, minus 3. Okay, so first n less than 0. So what is your u of k? U of k will not change. It remains the same. This is your u of k, which is tending towards infinity, plus infinity. Amplitude 1, 0, 1, 2, 3, 4. And u of minus k shifted by n, where n value is less than 0. So somewhere here, as I told, this is your n value. This is your u of minus k shifted by n. N is less than 0. So n somewhere here. This can be your 0. This can be n less than 0. So it can be minus 3. Okay, so I cannot write it as something. I will write it as minus 10, minus 11, minus 12 and so on. Okay, n less than 0. Somewhere your 0 is here. Minus 1, minus 2, minus 3 and so on. It can be minus 5, something, for example. Okay, now when n is less than 0, check it where the samples are getting overlapped. I don't have any samples of u of minus k plus n after n greater than 0. That is for k values which is 0, 1, 2, 3. I don't have any samples here. Okay, so if you multiply these samples with this, you get 0. Similarly, you have samples for u of minus k plus n towards left side. Something for from n equal to minus 5 means minus 5, minus 6, minus 7, you have the values. But u of k, this is your u of k. You don't have any samples towards left side. So when you multiply this, again you will get 0. So for n less than 0, you have y of n is equal to 0 for n less than 0. Okay, so what I am trying to see here when I am trying to calculate y of n, I am trying to check where the samples of u of k and u of minus k plus n overlap. Overlap means the samples exist for the same values of k. If they exist for the same values of k, then there will be some multiplication wherein you get 1 into 1, 1 into 1 and for all. So where you get some finite value. Now I don't have any samples which get overlapped for k values of this u of k or for k values of u of minus k plus n. But when similarly if this condition is n greater than or equal to 0. Now again u of k towards infinity, amplitude 1, this is 0, 1, 2, 3, 4. Now n greater than or equal to 0. Okay, on the time x of k, n is greater than or equal to 0. So somewhere you are telling that your n is greater than 0 means what? Somewhere here. Okay, this is 0, 1, 2, 3, 4. You are telling that n greater than 0. I will assume that it is might be 10 or 11 or 15 or 100 or 1000. So 0, 1, 2, 3 till 1000. You have this n is 1000 value. Some positive value because it is greater than 0. Okay, which is okay. So towards minus 1, towards minus 2, minus 3 and minus infinity with an amplitude 1. But because it is u of minus k, the samples lie towards left side. You are just pulling them towards the right side, shifting them by n. Now if you try to multiply this, you check it here. At minus 1 I don't have any value. At minus 1 I have 1. 0 into 1 0 plus. At 0 I have 1. Here also I have at 0 1. 1 into 1 1. So 0 plus 1 plus y plus, because your y of n is summation k equal to minus infinity to plus infinity. It is summation. It goes on adding. Okay. So similarly, if you go on writing the values for y of n, that is 0 plus 1 and so on, you need infinite amount of time to add these values. So we try to generalize with some equations. What is that equation again? Y of n is summation k equal to, where the signals start getting overlapped, at 0. So it is 0. And where do they stop? They stop at n, because you are telling that u of minus k shifted by some value of n. N for example 10. After 10 for u of minus k plus n, I don't have any samples. But since it is u of k, after 10 it is having samples towards plus infinity. So at 11 it is 1, but at 11 I don't have any value. So 1 into 0, 0. At 12 it is 1, but here I don't have any samples. So 1 into 0, again 0. So only till n, which assumes some value, okay, positive value, you have the samples. So the summation becomes summation k equal to 0 till n, and which is 1. Why? Because u of k into u of n minus k, which is 1 into what is alpha to the power k. I have to write this is into alpha to the power k. So what is your formula for summation k equal to 0 to n alpha to the power k? So it is general formula for summation k equal to 0 to n a to the power n. okay, sorry, a to the power k is 1 minus a to the power n plus 1 divided by 1 minus a, or a to the power n plus 1 minus 1 divided by a minus 1, provided for both a not equal to 1. Right? A should not be equal to 1. Similarly, now here you write summation. Okay. This k equal to 0 to n alpha to the power k. So using this formula, I will write it as 1 minus alpha to the power n plus 1 divided by 1 minus alpha. So this is your solution for y of n for n greater than or equal to 0. So I'll write here n greater than or equal to 0. So for complete n, like complete n, you can write it as 1 minus alpha to the power n plus 1 divided by 1 minus alpha u of n, because for n less than 0 your y of n is 0, and for n greater than or equal to 0 it is lying this, so it is u of n. From u of n exists from 0 to infinity, hence this is